My name is Neel Lindsby and I work as a PhD student at Volt, and I work with soil VOCs, and I have a background within biotechnology, and I have been working for the past 2 years or so as a microbiologist at the section of microbiology as well. I have previously worked with biological control, as when I worked as a microbiologist at the section for microbiology. I worked with biological control, where I tried to find bacteria and fungi that were able to inhibit plant pathogens in different crops. When I worked with biological control, I got to peek into the world of VOCs because you can use microbial VOCs to inhibit plants, some other microbes. So I started to peek into that, and then I saw the position at Volt, and I was like, okay, I want to go more in that direction. At Volt, I'm currently working on elucidating the relationship between soil microbial communities and VOC emission and consumption from soil in relation to drought and other climate change events. So my project focuses, the first part of my project looks at drought in the Arctic soils. And I think it's very interesting to look at that because drought is going to be more prevalent as global warming is going to increase the temperatures, we get more drought, and it's going to be more frequent. And therefore I also think it's very interesting to look at drought in places where drought has not been found, is not that prevalent yet. Very generally, what I have been doing and what a lot of other people are doing is when you want to measure microbial activity in soil, you take soil samples into a little vial, seal it, and then you measure the increase or decrease in CO2 in the air of the vial. Because a lot of the metabolic processes and so on in microbes end up as being CO2. So the more CO2, the more activity, the more they're doing. Soil, I think soil is very fun to look at, seeing as there's so many different variables within soil. There's a lot of different microbes in soil, both protists, microbes, bacteria, fungi, and a lot of life in soil. And then there's the complexity that you add more variables to soil. You have the soil matrix itself, the amount of soil organic matter, the amount of water in the soil, and if there's also the communication between plants and microbes within the soil through plants' exudates. So it's a lot of stuff that is difficult to, and therefore also interesting to look at. Thanks for listening.